Hey everyone, I wanted to go over a couple things about Lesson 8A and Lesson 8B. So there's a notes document, and then hopefully with this video explanation, everything gets a little bit more clarified, and you're able to go back and look at your answers and see if you can add any more detail. So for Lesson 8A, the main thing is we were trying to figure out between exothermic and endothermic reactions. So a couple things to remember the differences between those. Okay, in exothermic, you can think exo, X, like exoskeleton or exit. That's basically means out or released. So overall in this reaction, the heat is released. So in any reaction, there's energy in to break the bonds and energy released when the new products are formed, right? But we have to look at which one was bigger. So in an exothermic reaction, there would be more heat released when making the products than it took to break the bonds. So the amount of energy to break the bonds to make the reaction go was smaller than the amount of energy we got out when we made the products. And so that's why overall there was energy released, energy out. And as far as how this would, how we would observe this is a reaction that would feel hot to us because the energy from the reaction will be coming out and going into our hand. So out of the reaction into whatever's near it, our hand, then we would feel that as hot. Endothermic then is going to be the opposite. So endo, these are less common terms, but endocrinology, endoscope, endow, basically end means in or absorbed. So overall, heat is absorbed or put into the reaction. Okay, so again, when we're comparing how much energy did we need to put in to break the bonds versus how much energy came out to make the products, in an endothermic reaction, much more energy or heat. I really should change this word to energy. Much more energy is needed to be put in to break the bonds than was released in making the products. Okay, so energy in our case is heat, but it could also in other reactions be light or other things. But when we're talking about combustion and trying to compare endothermic, exothermic, that's all about heat, right? So that's what's going on. Exothermic heat is released, endothermic heat is absorbed or taken in. Okay. One of the next questions asked you about this graph and asked, why does it start at 0? So I noticed that some people maybe forgot to answer this question because the question was underneath the picture. So if you're going through it too fast, you missed the question. And then other people's answers were just a little vague. So remember that all bonds have a certain amount of potential energy. If you remember that simulation where you were moving the molecules back and forth, when they became balanced and had a bond, they had some potential energy, right? That was the lowest or most stable amount that they had, but it wasn't 0. So why this starts not at 0 is because reactant molecules have potential energy, right? They have some amount of energy to them. So that's what's going on with that graph. And then for this, I think that was pretty straightforward. But here we can see which one's winning, right? So reactants have some amount of energy versus the products, right? So if the products have more energy than the reactants, does that mean that the energy went into the reaction or came out of the reaction, right? So if the products have more energy, then it must be endothermic because energy went in. Here in B, if do we have the reactants compared to the products have less energy. So what must have happened to that energy? It must have gone out. It must have been released. Okay, so here, let me see here. Energy basically needed to come in, and that's endothermic. And then here, to have the products have less energy, energy must have needed to come out. So that is then exothermic. Okay. So that is some basics from part A. So now let's talk about lesson 8B. So there's always a bump or a hump in the graph, right? So there's that little bump there. No matter where the reactants or the product's energy starts, there's always that little bump. And that's what this video you should have watched, and that's what he was talking about in this video, that activation energy and what's going on. So remember, for a reaction to go, we need to be breaking those reactant molecules, right? So this is why I wanted you to think back to our molecules and our bond diagrams. That energy in, right? What's that energy in doing? That's what you need to explain in your question. Not just being too vague and saying, oh, well, energy is needed to start the reaction. Yes, that's true, but why? Okay, so please make sure you answer that question. And as far as relating it back to some of our concepts as well, right? So there's the molecule and bond diagrams and the simulations and what's going on with that energy. And also that connects back to the idea of combustion, right? Why do we need that match? But explaining, right? So yes, we need to use a match, but why? So keep going a little bit further in your explanations about what's going on at the molecular level, right? Why is that increase of energy needed? Why is the bump really there? And then in question 2, you had to identify which one was good for combustion. So most students picked diagram B, but again, we need some more explanation for why. So my hints to you is to focus on the main differences in the two graph options. So in A, the big difference is the reactants have a lower energy than the products. And in B, the reactants have a higher energy than the products. Okay, so I just talked about it earlier in the video a little bit, but also try and think, what does that difference mean, right? And then relate this back to the heat and what you know about combustion reactions. So hopefully, if you're looking at this, just be able to explain more in detail about what's going on. Why would you pick B for a combustion reaction? What specifically about graph B is making you choose it versus graph A? Okay. So hopefully now you can go back and revise your worksheets and put in any extra details, and that'll help with when I go and put in your grades if you've actually revised them. If you still have any questions, just let me know.